Hi everyone, welcome to Vedantu NEET English. I'm Diksha 𝐂𝐡𝐞𝐤 your chemistry master teacher. So everybody let me know in the comment section if I am clearly visible and audible to you so that we can start with the session of equilibrium, chemical plus ionic equilibrium. So everybody let me know in the comment section if I am visible and audible to all of you or not. Yes students, everybody. Hello, hello, hello. Hello. Okay. I think I'm visible. Okay. Shall we start? Yes, Anathya, Sukanya, Sanjay, Painist. Paininist? Do you cause pain or what? Manasi, 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 Roshni, Bhavan, Bhavani. I think I need to check on my specs. I'm not able to see your names. Parvesh, yes. Okay. Yes. So everybody, let us start the session without wasting any time, right? Okay. And I really hope so that you are doing well with your revision. Everything is going fine. You are practicing the questions as well, right? Okay. Yes. My health is, yeah, perfectly fine. Don't worry about that. I'm fine, right? Okay. Chalo. Now, let us talk about the first thing, that is chemical equilibrium, right? So what is exactly equilibrium? Equilibrium, we say that it is dynamic in nature. Dynamic means if I say that I have a tap here, okay, there is some tap here, tap over here, and there is one bucket here, right? And this bucket also has a hole, right? Now, what is actually happening? Water is coming out on this bucket, and from this one, water is also going out. So what will happen in reality? This water will remain constant. The water in the bucket will remain constant, but we can't say that nothing is happening here. So basically, water is coming from the tap and water is also going from the bucket at the very same rate, right? So what we can say here, that it is actually change is happening, but to us, if we see only this bucket, we can see this is a constant thing. So constant is called equilibrium, and the dynamics that it is following, the change, right? The rate in the addition of reactant, consumption of products, all this is dynamic in nature. So that's why we call it, it is dynamic in nature. That's why we say equilibrium is dynamic in nature. So let me just see, I think my specs, they are really not fine. So let me just wear another one, right? Think so. Just give me a second. Okay, you play piano. Nice. Nice, nice, nice. So let me just see if this looks fine. I think this looks fine. Okay, chalo. So I'll wear my very old specs when I was like really of your age, right? Okay, so this is chemical equilibrium. Now let us firstly, let's just speed it up, right? Rate, right? If you talk about the rate here, rate is same and constant. Rate, we can say that rate should be constant here, and rate of reactant, forward reaction and backward reaction should be equal to each other. That means when we say rate of forward should be equals to rate of backward reaction, right? But when we talk about the concentration here, for concentration, we are not saying that concentration should be constant only, concentration should be same only. For this, we are saying that concentration of reactant should be constant, concentration of product should be constant. But we are not saying that concentration of reactant should be equal to the concentration of product. If it is equal, great. If it is not equal, even then it is fine to us, right? So concentration may or may not be same, but it will always be equal. For that, we have few graphs here. Now you need to tell me which of the following graph is correct or incorrect, A, B, C. And here also I am drawing a graph A, B, and this is C. Now guys, you need to tell me which graph is correct and which graph is incorrect, okay? So, firstly, let us talk about the graph of concentration with the time. If you talk about the graph of concentration with the time, what we have to remember, concentration may or may not be same, but it should always be constant. So if I say green is representing the concentration of, let's say, products, because product initially were 0, it is representing product, it is representing reactants. Okay, this is product and this is reactant, right? This is product and this one is reactant, right? So here concentration of product and reactant are constant at a certain point, that is equilibrium point, but we are not saying that they are equal to each other. Fine with us, right? That is correct. Here also it is not equal, but it is constant. It is also correct. It is constant also and it is same also. So you're like, okay, we are fine with that as well, right? But when we talk about the rate graphs, right? Now this is A, B and C. Let me know in the comment section which of the following is correct and which of the following is incorrect, keeping in mind that the rate of forward reaction should be equals to the rate of backward reaction. That is a condition of equilibrium, right? So that means the rate should be constant and the rate should be same in this case. So let me know in the comment section A, B and C with respect to rate versus time graph, which of the following is correct or incorrect here, right? Okay, yes, okay, everybody, all are correct. No, yaar, all are not correct. How come all are correct? Here it is not equal. This is rate of, let's say, backward. This is rate of forward. Rate of backward, rate of forward. Rate of forward, rate of backward. Now, here rate of forward is not equals to rate of backward, right? So, this is a wrong statement. Here rate of forward is not equal. So, this is a wrong graph. Here rate of forward and backward are equal. So, this is the correct graph. So, in rate versus time, only this particular graph is correct, because only this graph, the rate is constant and same as well, right? Okay, okay. For concentration, all of them are correct, but for rate, only C is the correct answer, right? Okay, okay. Now next is properties. Right, what are the properties of equilibrium? Properties, first properties, it is dynamic in nature. Dynamic means, as I told you, to us it is like nothing is happening, but in reality it is changing. But the rate of change is constant. That is why to me nothing is happening, but in reality, in a very clever manner, right, the concentrations are changing, but to me it is same. Right, now second is rate of forward is equals to rate of backward. Third is any side. Equilibrium can be achieved from the reactant side or the product side, right? Fourth is catalyst. Now, it's a very, very important point from where the questions in your NEET are asked, right? Catalyst alter rate of approach, but that means it will alter the activation energy that we will talk about in chemical kinetics, right? But does not change the state of equilibrium. It will have no effect on the state of equilibrium. It will not alter the Kc here, right? That will remain the same. Last is delta G, that is Gibbs free enthalpy, should be equals to 0 at equilibrium, right? Okay. Next is law of mass section. Guys, next is law of mass section. Now everybody see this here. Law of mass section is a derivation where we use this particular thing, that rate of forward is equals to rate of backward, right? Okay, from there we derive it, and what we get this particular thing, that is the equilibrium constant, right? So equilibrium constant represented by Kc or Ke, right, that is equals to the concentration of products raised to power the stoichiometry divided by the concentration of reactants raised to power the stoichiometries. That is called the equilibrium constant, right? Okay, yes. Oh, really? Yeah. You only tell me all these things. Now, next is Kp. Okay, other one is Kp. Now, I'll just draw it here. Then next is Kx. If you talk about Kp, right, P denotes the pressure, right? Now, if you want to write any equation, any reaction in terms of Kp, one condition that you need to have is any term, at least one term in that reaction mixture should be in the gaseous form. At least one species should be gaseous. Only then you can write Kp there. So Kp is equals to Pc raised to power C. PD raised to power D, that means the pressure of products raised to power the stoichiometries divided by the pressure of reactant raised to power the stoichiometries. Okay, next one is Kx. Okay, one more thing, and pressure we will only write for those things which are actually gases. Something is solid, something is liquid, we can't write pressure of that gas, right? Okay, and here when you're writing the concentration, right, here also we have one very important point, that the concentration, wait a minute, the concentration of pure liquid and pure solid will be equals to 1. If there is pure liquid, pure solid, you will take the concentration as unity only, right? Okay, next is Kx. What is Kx? Very rarely you will use this, but if they ask you this, how you will answer this? This is mole fraction, equilibrium constant in terms of mole fraction, that will be equals to mole fraction of products raised to power the stoichiometries, mole fraction of reactants raised to power the stoichiometries, same way, right? Now let us talk about the units here. Units of Kc is going to be mole per liter delta Ng. Delta Ng is the number of gaseous moles of products minus, and here I am talking about gaseous moles, number of gaseous moles of products minus number of gaseous moles of reactant, that is called delta Ng. Acha, now what is the units of Kp? Kp, guys, what is the unit of Kp? Kp is equals to atmospheric raised to power delta Ng. Okay, atmospheric raised to power delta Ng. Reason is because the units of concentration is mole per liter and the units of pressure is atmospheric, that is the reason. Now, if you talk about Kx, that is going to, because these are dimensionless only, right? So it will have no units here, right? Okay, now very important relation between Kp, Kc and Kp and Kx. Now, if you ask me, ma'am, from where the questions are maximum, they ask you, maximum questions are asked from Kp and Kc relation. Very rarely, if they want to pick out something new, a new question, then they can ask you question from Kp and Kx also. But right now, if you see your previous year question, you will only see question from Kp and Kc, right? Okay, but still I would advise you to just go through this particular formula as well, right? Kp is equals to Kc RT delta Ng, right? This is Kp is equals to Kx P delta Ng, that is the formula. Now, here you will put the value of R as 1 by 12 liter atmospheric per mole per Kelvin. That is going to be the answer, because 1 by 12 is nothing but it is 0.0821 only. So, to make the calculations easy for you, we put the value as 1 by 12, right? Okay. Now, next guys, now here I have given you one example, that for example, there is one reactant, like this is the reactant. Now, here I know that at least one species is in the gaseous phase. So I can write the Kp value also here. Kc, if I want to write the Kc value here, how you will write the Kc value? Kc value, I will ignore this particular term in Kc, right? Reason, because the concentration of pure liquid or pure solid is going to be 1. That is why we have ignored this term, and it is C raised to power C divided by B raised to power B. Okay. Next is factors on which K depends. Now, from here also very simple questions are asked. Let us see how these questions are asked. Okay. It's like when you reverse the reaction, when you add something in the reaction, you multiply that reaction with something, you divide it with some integer, you subtract something out of it, you add something, some two reactions, then what is the effect on the equilibrium constant, that we are going to see here. Now, let's say I have a reaction, that is A give rise to B, right? Now, if I am reversing that reaction, let's say it is B reverse A, then here I am saying it is K1, here it is K2. So K2, if I am reversing that reaction, then K2 will also be equal to 1 by K1, right? If I am multiplying, for example, I am multiplying this particular reaction, let's say with N. Na give rise to Nb. So if I multiply this, now I am saying the answer is K2. Now the new K2 is going to be the old K2 raised to power N, okay? New K2 is going to be the old rate constant raised to power N, that is Originally it was K1, so raised to power n because I have multiplied this with n. Next is if I divide, I am saying if I divide this particular reaction with n. Now, can I say division with n means multiplication with 1 by n? That means, can I say if here I have multiplied with n, it was raised to power n. If here I have multiplied it by 1 by n, it will be raised to power 1 by n, right? Next question is if I add two reactions. Let's say you have one more reaction, that is C give rise to D, right? And here it is K2, right? And here this is K2. And you are adding these two reactions, A plus C give rise to D plus B, okay? When you add this A and C you have added, this B and D you have added. Now it has become K3. Now K3, because I have added two reactions, so it will be the multiplication of rate constant of these two, K1 multiplied by K2, that is K3, right? So K3 is equals to K1 multiplied by K2. Next we have, if I subtract these two reactions, if I subtract, let's say it is A minus C raised to power, this is D minus B, or you can say B minus D. B minus D. Now this is the new K3 because I have divided, because I have subtracted two reactions, so it will be in the division. So that means K3 is equals to K1 divided by K2, that will become equals to K3, right? So these were the direct relations of your rate constants, right? Okay, yes, thank you so much Mumtaz, thank you so much. Okay, now next is factors on which equilibrium constant depends, okay? Now let's talk about the factors on which equilibrium constant depends. Okay guys, yes, till here everything is clear to all of you? Yes guys, thank you, thank you, thank you. Vipul, Bhavana, Roshni, till here everything is clear, is it? Karthi, yes students, let me know in the comment section, right? Yes. Now, yes Mohammed, okay. Now, factors on which equilibrium constant depends. On which equilibrium constant will depend, let us see that. Log of K2, how equilibrium constant depends on the temperature. That's a very, very important thing, right? So if you talk about the equilibrium constant, how it depends on the temperature, so we have to see whether it's an exothermic reaction or an endothermic reaction. First question is asked directly from this particular reaction. They can give you some values. They can ask you the value of K2, value of K1, value of K2 by K1, anything they can ask you, right? So the formula is log K2 by K1 is equals to delta H by 2.303 R bracket T2 minus T1, T1 into T2. Now, if I say that it is a exothermic reaction, that means delta H is negative. If this is negative, right, and we know that temperature we are increasing. T2 I am taking that temperature is increasing. I am assuming that temperature is increasing, right? So if temperature is increasing, that means this will also be positive. If this is positive, that means this whole value is going to be positive. That means log of this thing, K2 by K1, is going to be greater than 1. Log of anything is greater than 1 if the value that is inside the log is also greater than 1, right? That means K2 will be greater than K1. Now, can I say that T2 is greater than T1, K2 is greater than K1? So, when we are increasing the temperature, K2 rate constant is also increasing. So, there is, wait a minute, it is negative, oof, I solved it for endothermic. I thought it is positive written here. Oops, I'm sorry. I solved it for positive. Okay, so I'll firstly tell you about the positive only. If it is an endothermic reaction, delta H is positive. So if here it is positive, whole value will be positive. If this whole value is positive, that means log of K2 by K1 should be greater than 1. It should also be positive. If this is positive, that the value inside should be positive. That means K2 is greater than K1. Now, that means for an endothermic reaction, as temperature is increasing, K2 is also increasing. So can I say there is direct relation of T and K in a endothermic reaction, right? Okay. Now we will solve this for exothermic reaction. Now let us solve this for exothermic reaction. For an exothermic reaction, this is negative. This thing is positive, right? That means this whole thing will be negative, right? Okay, that means this whole thing will be negative, negative because this all are positive only. That means log of K2 by K1 will be, log of K2 by K1 will be negative. If anything, if you say the log of something is negative, that means the value inside it is negative, right? Okay, that means K2 by K1 is negative. That means K2 is less than K1. K1 is greater than K2. That is the correct answer. So as we know that T2 is greater than T1 because we are assuming that temperature is increasing, right? Temperature is increasing, rate constant is decreasing. That is the reason for an exothermic reaction, they are inversely proportional to each other. So directly we learn that from this equation we know, right, directly we can say for an exothermic reaction, temperature and rate constant are inversely proportional. For an endothermic reaction, temperature and rate constant are directly proportional to each other. Right? Okay, directly proportional to each other. Right? Okay, yes. Less than 1. Less than 1. I'm so sorry. I should write it as less than 1. Right? K2 by K1 is less than 1. Right? And there K2 by K1 is greater than 1. It should be less and greater than 1. Right? Okay, got it? By mistake I spoke that. Right? Okay, understood? That thing is clear to everybody. Now you just have to remember this thing. Just remember this thing, that for exothermic reaction it is inversely, for endothermic it is directly proportional. Okay, next thing guys, everybody, next we have, wait a minute. Now let us see application of equilibrium constant, right? Its application, rate is slow, fast, what it is there, right? So if we talk about the extent of the reaction, if they have given you that the reaction is, if they have given you, wait a minute, it should be, here it should be plus, here it should be minus, right? Okay. For example, they have given that the equilibrium constant is greater than 10 raised to power 3. That means the reaction is very fast. It is product dominating reaction, right? If I say the rate constant is between -3 to +3, that means 10 raised to power -3, 0.001 to 10 raised to power 3, we can say it is intermediate. It is both going here and there, right? If I say rate constant is less than 0.001, that is 10 raised to power -3, then we say it is reactant dominating. It wants to go backward in direction. It is a very, very slow process, right? Now let us talk about the direction of the reaction. Now direction is predicted by the reaction quotient, right? Okay, right? Okay. Thank you, Mumtaz. Thank you. So direction, that's why I take time to prepare these notes for you, right? So direction of reaction. Now, firstly, you have to understand what is QC. Reaction quotient is product raised to power stoichiometry by reactant raised to power stoichiometry only. But at that point, it should not be at equilibrium. If it is at equilibrium, then QC will become equals to KC. Now, how you will tell with the help of QC and KC whether it's a forward or a backward reaction, right? So, firstly, if I talk about QC is greater, take it as KC, take it as QC. Now, always remember you have to match the value of KC, right? But you can't change KC. You can only change QC, right? Okay. Now, this is KC, this is QC. QC we are saying is greater than KC, right? Now, if you have to become equal to KC, you have to go backward in direction and then only it will become equals to Kc. Now when I am saying these two are equal, Qc is greater than Kc, right, it has to go backwards. That's why we are saying that the reaction will proceed backwards. Just a way to remember things, right? Qc is equals to Kc, it is at equilibrium when Qc is less than Kc. This is Qc, right? This is Kc. We are saying that Qc is less than Kc. This is Kc, Qc is less than Kc. So now we have to move forward to become equals to Kc. That means it will be a forward reaction, right? Okay, Ji, it will be a forward reaction. Next is degree of dissociation or association. Mostly though we talk about dissociation only. I'll take one example here. Let's take one example. Let's say you have 2a give rise to 3b plus c, right? I am saying that alpha is the degree. Alpha is the degree, right? We are saying the definition is number of moles dissociated by initial value, right? So always when you are solving the questions, right, initial value, either it will be given in the question. If it is not given to you, then you will take stoichiometry as the initial value, right? Okay. So now I'll take initially you have only reactant, so I'll take 2 as the initial value, right? So I'll take I'll take 2 as the initial value, and this is 0 and this is 0, right? This you have to understand full equilibrium, otherwise it will go out of your head, right? Now if I say that I need to, something is getting reacted, something is getting consumed, so how you will take it? It will be stoichiometry multiplied by something x, right? This is stoichiometry multiplied by x. Stoichiometry is 1, so it is x only, right? This much we are getting, this much is consumed and this much is getting formed here, right? Now x is the number of moles that were, how many moles were getting, number of moles dissociated. How many moles were dissociated from the reactant? That is 2x, right? Divided by how many initial moles you had? That is 2. So answer is going to be x. So that means x is the degree of dissociation in this particular case. Now let's assume that, let's say that, wait a minute. Let's say that there is one student who said that, ma'am, why you are taking it as 2? Ma'am, I want to take initial moles as 1. Okay, some student, he has taken initial mole as 1. Okay, he has taken initial mole as 1. Right, because in some books you will also see that initial moles they take 1. It is totally your choice what you want to take, right? How the question is becoming easier for you, right? Okay, so if you take initial moles as 1, this will be 0, this will be 0, right? Now if you take out something from there, it will be 1 minus 2x, right? Because 2 multiplied by x, this will be 3x, this will be x, right? Here alpha, here you will say alpha is going to be, moles dissociated is 2x, initial mole is 1. So it is 2x is the degree of dissociation for the same reaction, but here initial moles you have taken as 1, right? Okay, so accordingly the full question will get vary. Answer will be the same in the end what they answer, what they ask you, because in this way what will happen now, the value of x will also change, because for x value they will give you some hint in the question, right? That for example they can give you, you had 2 moles, if 2 moles were initial, then 1 mole were getting dissociated, or they can say half of initial mole is dissociated. So in this case x will become equals to 1 by 2 into initial mole is 2. In this case x will become equals to 1 by 2 initial mole is 1. In this case x is half, in this case x is 1. If you put the value of alpha here, alpha is equals to number of moles dissociated is 2x divided by 2, it is x. X is what? X is 1 only. Here alpha will become equals to 1, and if I put the value of x here, x is 1 by 2, it is 2. Here also alpha is 1. This is what I was telling you, that the end value will remain the same no matter which path you follow. It's totally your choice. You want to take the initial moles as stoichiometry, or you want to take initial mole as 1, it's totally your choice. Is that clear to everybody here? Is that clear? Yes, everybody. Happy Pongal, beta. Happy Pongal. So, is that clear to everybody here or not? Yes, students. Should I erase this? Hanji. So, it's a very important concept to understand ionic equilibrium as well. Right? Okay. Now, next is Kc calculations and Kp calculations. So, understand this. I will not make you cram anything here. Right? So, Kc calculation, simply how you will understand that. So, this is a reaction that is given to you. I am taking initial mole as 1. Okay, let's see. Because here I told you that's totally your choice what you want to take. You want to take initial mole as 1, let's take initial mole as 1. 1, 1, 0, initially it was 1. I am saying that this is also 1 and this is initially 0. Right? Now, what we are doing here, X amount is dissociated stoichiometry multiplied by X. Stoichiometry multiplied by X, stoichiometry multiplied by X. Right? Now, students, understand one thing. What is Kc? What is the value of Kc? Kc for this reaction will be equals to C raised to power 3 divided by B raised to power 2, A raised to power 1. That means you have to put the concentration values of C, A and B. Concentration means molarity. Molarity is number of moles divided by volume. So I'll take volume of that vessel equals to V. Okay, I'll take volume as equals to capital V. Now all these reactants and products are in same container. So I'll take the container, the volume of that container is V. Right? Okay. Now this volume is taken in milliliter. Volume V is in, liters. Not in milliliters, this is in liters. The reason? Because molarity is equals to number of moles divided by volume of solution in liters. Right? Okay. So number of moles we have already encountered here. Number of moles is 1 minus x, 1 minus 2x and 3x. Number of moles only we were calculating there. Na? Here when we are telling you that this is the number of moles only. 2x is dissociated. This is the number of moles in that reaction at equilibrium. In that reaction at equilibrium, in that reaction at equilibrium. So number of moles divided by capital V, concentration of A, concentration of B, concentration of C. Put this value here and this is the equation that you will get. Right? Now, ma'am, first thing is they can directly give you this particular thing in the exam. Right? Okay. You have to tick mark that thing. Right? They will give you X amount of moles are dissociated. Take initial moles as 1. Right? According to that, you will just follow these steps and solve the question. Or they will give you some hint. Some hint like they can give you that 5 moles were dissociated. 10 moles of A were dissociated. So that means X will be equals to 10. Right? Okay. 50% of moles were dissociated. That means half of moles. If initially you have taken 1, that means half of this was dissociated. Right? So something like this will be given to you in the question. That will be hint for X. Right? You just have to follow this thing that Kc is nothing but it is concentration raised to power stoichiometry. So, concentration is in molarity. That is number of moles divided by volume. Right? Okay. Is that clear? It does mean volume doesn't affect the equilibrium. If so, effect would pressure have forward or backward reaction? Yes, you are absolutely right. If that cancels out each other, right? If volume is cancelled in the equilibrium Kc, then Kc is not dependent on the volume. Okay, then it will not be dependent on the volume. Okay, yes. Now, next is Kp. Now let's talk about the Kp calculations. For Kp calculation, do the same thing. Calculate the number of moles here. But we know that from this formula that partial pressure is equals to mole fraction multiplied by total pressure. Right? Okay. So we have to calculate the value of this partial pressure for each species here. Partial pressure, first you need to have mole fraction. Mole fraction is always equals to number of moles of that component divided by total number of component that you have. Right? So what you will have, these are the moles. You will solve the total moles. the total moles will be equals to, total moles here will be equals to 1 minus 2x plus 1 minus 4x plus 3x, that will be equals to 2 minus 3x. So these are the total moles. So each mole will be divided by the total mole here. You will get the mole fraction, right? Now when you multiply the mole fraction with the capital P, pressure, then you will get this particular thing. You will just put this partial pressure into this equation, because we know that here it should be Kp will be equals to pressure of B raised to power 3, pressure of A raised to power 2, pressure of C raised to power 4, right? So you'll just put this value here and this is what you will get in the end. Is that thing clear? Yes, students, is that thing clear to everybody? Right? Now, next is vapor density. If they ask you any question regarding vapor density, what is vapor density? Very simple. Vapor density, X is equals to D minus D divided by Dn minus 1, right? Okay. So how you will calculate this? That will be equals to capital D is the, basically this X is nothing but it is the degree of dissociation, right? Okay. So degree of dissociation is equals to capital D minus D, vapor density of reactant minus vapor density of mixture divided by vapor density of mixture bracket N minus 1. What is N? That is stoichiometry of product divided by stoichiometry of reactant. Very, very rarely they can give you this particular question, but if they give you, you should know the formula at least, right? Okay. Next is a very important relation, that is delta G. This is a very, very important relation, okay? From here, a lot of questions are asked in the previous year questions, right? Okay, so here it is, delta G equals to minus 2.303 RT log Kc. They can give you, calculate the value of delta G, calculate the value of Kc here, anything they can give you, right? What is R is universal gas constant, temperature will be given to you. Simple question from where questions are asked. Now, next is this particular chart, okay? Okay guys, let's understand this particular chart here. Beta R value will be 1 by 12 only, okay? So we'll put it as 1 by 12, right? Okay. So Kc, if we are saying that Kc is greater than 1, that means this is positive, that means this thing will be positive, right? Positive, you can say that when the log inside it is greater than 1, then this whole value is positive. If this whole value is positive, then this full value will be negative. Delta G negative means it is a spontaneous reaction, right? So what we can say, spontaneous reaction tend to move forward only, right? Okay. Next is Kc is less than 1. If it is less than 1, then this full value will be negative. If this is negative, then delta G will be positive. Positive means it is a non-spontaneous reaction. That means it does not want to go forward, it will go backwards. Next is when Kc is equals to 1. Kc is equals to 1 means this full value will be 0 because log 1 is 0, right? Okay, so this full value will be 0, delta G is 0. That means there is no shift, it is at equilibrium, okay? It is at equilibrium. Okay, Ji, got it? Okay. Now, next is Lee-Chartler principle. Now, let us talk about Lee-Chartler principle here, right? Okay, students, why can't I see your attendance here? Why can't I see your attendance here? Let me know in the comment section. Why are you not attending your classes? Right? What's the issue? What's the issue with you guys, huh? I can see you guys are not very interested in studying. All you guys are interested in this or that stuff. But study, though, I rarely see you guys doing anything in that. And I feel very sad about it. Very, very sad about, not me, about you guys, yeah. Why you guys are not interested in good content? What's the problem with you? right? Do you don't want to study? Even if you take the class, you are in the class, even then there is no energy in the comment section, nothing. It's just that ma'am is ma'am. You just, as if you just want that, you want that I want to crack NEET, but I don't want to do anything. Is that what you want to do, guys? Is that what you're looking for? Right? Then you will say, ma'am, the frequency of the lecture, ma'am, why you're not taking the sessions? That's the reason we don't take the session, because we don't feel that you guys are interested in that. You have to put some input, na? Chalo guys, I'll give the break after this. If I see that some students are joining, then only I'll continue the session. Okay? Otherwise, so there is no benefit of this, right? Okay? ऐसे ही stupidly I prepare all these things for you, right? I think I am stupid or what? Sometimes I feel sad about myself also, that I should not do these things for you. I should just get some PPT and teach you guys, right? है ना? Sometimes I feel like, should I even do these kind of things or not? I should stop. है ना? I should stop here only. I should stop doing these stuff for you. Okay, again today also you guys disappointed me. Thank you so much for that. Okay, Lee-Chartler principle. Now, guys, if you talk about the Lee-Chartler principle, it is going to do everything opposite of what you say, right? Okay, if you say it go here, go on right side, it will go on the left side, right? So everything will be opposite here. So opposite to the increase or decrease in the concentration. So if you want to increase the concentration, let's say you increase the concentration of reactant, it would want to decrease the concentration of reactant and move in the backward direction. If you increase the concentration of product, it would want to decrease the concentration, sorry. If you increase the concentration of product, it would want to decrease the concentration of product and move backward, right? If you increase the concentration of reactant, it would want to decrease the concentration of reactant and move forward, right? So oppositely it will behave. Next is the pressure. Now, if you increase the pressure, now pressure has a very, very important, usually the questions are asked on pressure and the temperature. From these two cases, the questions are asked from Lee-Chartler principle. If you talk about the pressure here, pressure, when you increase the pressure, that is going to move towards the number where number of moles are less. If you decrease the pressure, it is going to move on that side where the number of moles are more. Okay, so that means you can just remember that pressure and number of moles. If you increase the pressure, it will move on that side where number of moles are less. For example, you have some reaction, that is 4A give rise to 2B. This is also gaseous, this is also gaseous. Now tell me, when you increase the pressure here, will it move backward or forward? If you increase the pressure here, it would want to go in the less number of mole side. That means it will go in the forward direction, right? That means it will go in the forward direction. Okay. Now, next is volume. Volume is inversely proportional to the pressure, right? So, if you talk about the pressure here, that you increase the volume. Increase the volume means you decrease the pressure. So, when you decrease the pressure, it moves in the where number of moles are more. So, equilibrium will be shifted towards that direction where number of moles are more. Okay. Next thing is temperature. Temperature, as I told you, the simple variation, exothermic and endothermic. For exothermic, it is inversely proportional. For endothermic, it is directly proportional, right? Okay. So, as you can see that if you increase the pressure in exothermic, the equilibrium constant will decrease. That means it will go in the backward direction. Okay. Now, next is inert gas. Inert gas at constant volume, it will have no effect. But at constant pressure, it will move towards that direction where number of moles are more. Where number of moles are more, it will move towards that direction when you add some inert gas into it. Now, ma'am, how you will predict whether it's an exothermic, endothermic reaction? So, there are some important points, right? Haber's process, contact process, that means formation of NH3, formation of SO3, all these are exothermic in nature, right? That means this thing you will apply here, right? Okay. Now, if you talk about combustion, all combustion reaction, they release heat. but all the decomposition reaction, they require heat. They're endothermic in nature, right? And N2 plus O2 give rise to NO is also endothermic in nature. These are some very, very important reactions and some very, very important processes. Okay, got it? Now, let's move towards the revision of ionic equilibrium. Okay, okay, students? Yes, everybody? Okay, ji, chalo. Now, first thing is, where volume cancels out, won't that mean this? Where we no difference, even pressure has no effect? Would that be a true or a false statement? Cancel out. That is a true statement. It means that particular process don't have that particular reaction, right? It does not have any effect on the volume or the pressure, right? Okay, yes. Now let's talk about electrolyte and non-electrolyte. Electrolyte are, if you talk about non-electrolyte, that is not dissociated or associated. Just like you have glucose, urea, fructose, these are non-electrolytes. So here alpha is equals to 0. Degree of dissociation is 0. But if we talk about electrolytes, there are strong electrolytes and weak electrolytes as well. Strong electrolytes which has alpha is equals to 1. Weak electrolytes, alpha will be from 0 to 1. That means if you have 50 molecules of HCl, 50 molecules will dissociate into, all the 50 molecules will get dissociated into H positive and Cl negative. Total after dissociation, you will have 100 molecules, 100 ions, right? Now, but if there is a weak electrolyte like CH3COH, it's a weak electrolyte. So in this case, if you have 50 molecules, maybe out of that 10 molecules will be dissociated, maybe 20 will be dissociated. So alpha will not be 100%. That will be between 0 to 1, right? Now, ma'am, how can we say something is a strong electrolyte or a weak electrolyte? So simply I'll tell you some very good examples here. Strong electrolytes, all the salts are strong electrolytes. Talking about acids and bases. So acids, like you have mineral acids like H2SO4, HNO3, HClO4, HClO3, HCl, HI and HBr. These are strong electrolytes. But if you talk about weak electrolytes, just subtract one oxygen from here, so it is H2SO3. That is a weak electrolyte. Subtract one oxygen from here, you have HNO2. That is a weak electrolyte. Now, HClO4 and HClO3, both are strong, but subtract one oxygen from here. That means HClO2, and again subtract one oxygen from here. That means HClO. They are weak electrolyte. Next is talking about the hydrides of halogens, HCl, HBr, HI. These are strong electrolytes, but HF is a weak electrolyte. Okay. So these are some confusion that creates a lot of confusion in students' head. Rest I will talk about the weak electrolytes. Other weak electrolytes are organic acids, H2CO3. It's a mineral acid, but it's a weak electrolyte. It's a weak acid. H3BO3, boric acid is also a weak electrolyte. All the oxo acids of phosphorus are weak electrolytes. HCN is also a weak electrolyte. Now, bases are very, very simple. Right, in bases, just remember alkali metal hydroxides. You'll say, ma'am, will anybody ask this question? To solve the numerical of ionic equilibrium, sometimes you need the knowledge of this particular thing, right? Because you need to know whether it's a strong acid, strong base, weak acid, weak, what is it, right? So, bases are alkali metal hydroxides plus BaSO4. Alkali means the group number 1 hydroxides, plus from group number 2 you have barium hydroxide, which is a strong electrolyte. Weak bases are alkaline earth metal, all the group number 2 bases except for barium hydroxide, which is in the list of strong electrolytes. Rest is we have, rest students we have 1 degree, 2 degree, 3 degree amine, right? Organic bases, NH4OH. These are your weak bases and they are called as weak electrolytes. Okay. Now, talking about the journey of acid and bases, right? Which is a Arrhenius base, conjugate acid. From here also the question, very simple questions are asked, right? So just go through this. Arrhenius acid and bases. So if we talk about Arrhenius acid, it gives H positive in water, and base is one which gives OH negative in the water. That is the definition of Arrhenius concept. Now, most important concept here is Bronsted-Lowry and Lewis acid base concept, right? That is the most important concept. Now, Bronsted-Lowry concept talks about only proton. He says that acids are proton donors and bases are proton acceptors. He is not talking about dissolving it in water. He is saying acids are proton donors, they will donate proton, bases will accept the proton. Now, if you talk about amphoteric, what is amphoteric species? The one which donates and accepts both. Now, if it donates H positive, it will become CO3 2 negative, which is a acid. Now, it is acting like an acid because it is losing a H positive. It is donating H positive. If it accepts H positive, it will become H2CO3. Now, it is acting as a base. So, which acts as both Bronsted-Lowry acid and bases, that is called amphoteric, right? Okay, amphoprotic you can say, not amphoteric, it is amphoprotic, right? Okay, amphoprotic. Now, next is an acid. After losing H positive, it will form a conjugate base, right? And a base after accepting proton, it will form a conjugate acid. Opposite of that thing. Now, always remember, if this thing is strong, then this thing will be weak. If I say something is a good acid, then it will form a weak conjugate base. If it is a weak acid, it will form a strong conjugate base. So they are opposite to each other. Next is a very, very simple concept from where also the questions are asked, that if you have an acid, right, and its conjugate base. Now, if I say this is an acid, this is its conjugate base. Now, we are saying that the rate constant of the acid and the rate constant of the conjugate base, when it is acting like a base, when it is accepting the proton, it is acting like a base. It has Kb, right? And C is for conjugate base, right? This is Kb, right? Now, we can say that multiplication of these two things, and here I am talking about only that conjugate base, multiplication of these two will be equals to 10 raised to power minus 14. That means it is equals to K raised to power, it is equals to Kw. Kw is what? 10 raised to power minus 14. Okay, so that is going to be the answer. Next is the concept is Lewis acid base concept. Now, what is a Lewis acid base concept? Here, all the acid and bases are like satisfied here. Now, he is not talking about any proton thing. He is saying that simply acids are electron deficient in nature. All the cations, except for these kind of cations, which are not exactly cations, they are basically, when they have attached some protons here, they are acting like a, it may look like they are cations, they are also cations, but they are not those cations which are electron deficient, right? Okay, they already had some lone pair, but now they had accepted one proton from outside. That's why they are electron deficient. So these two are not the Lewis acids, right? Next is which are electron deficient. Cation accept this. Multiple bonds, if they are forming, then also it is a Lewis acid, right? Lewis bases are which are electron rich in nature. They have lone pairs, they are anions, right? Okay, these are Lewis bases, right? Next is, students, we have ionic product. Ionic product is Kw is equals to H positive concentration, OH negative concentration. At 25 degrees Celsius, at 62, at 90. What you will observe here, I'll firstly tell you this thing here. Have you seen this formula before? Have you seen this formula before, right? We have seen this formula before as well. From this formula, we know that if you talk about this particular thing, when you have dissolution of an acid, dissolution of some water, right? In that case, it is a, wait a minute, it is a endothermic process, right? It is an endothermic process always and always, right? That's why delta H is positive. That is the reason from this equation we know that temperature and K are directly proportional to each other. This we have seen in chemical equilibrium, right? Because they are directly proportional to each other. Can I say as K is increasing, T is also increasing, or you can say as temperature is increasing, rate constant is increasing. If rate constant, with increase in temperature, rate constant is increasing, this rate constant increases, that means the concentration of H positive and OH negative will also increase. If concentration of H positive increases, pH will decrease here, right? If OH negative increases, POH will decrease. Ma'am, how can you say these two things? Because pH is equals to minus log of H positive. POH is equals to minus log of OH negative. That means H positive is inversely proportional to pH. OH negative is inversely proportional to POH. That is why when you increase H positive, pH decreases. When you increase OH negative, POH decreases. Right? Okay. So from here, that is the reason what you have observed here. That is the reason what you will observe here. In this case, pH will be equals to 14. Here, pH will be equals to 13. Here, pH will be equals to 12. The midpoint will vary here, right? So here what we can say that at 25 degrees Celsius, that means here I am not talking about the pH, I am talking about the pH scale, right? The pH scale is 14. It will be 1 to 14. It will be 1 to 13. It will be 1 to 12. The scale that you study about the pH scale, that is why it is still 14. Because we are always talking about the room temperature, right? That is why we know that room temperature will always not be 25 degrees Celsius. That's why in our experiments, the value varies, right? So Kw, if nothing is mentioned, they are mostly talking about Kw is equals to 10 raised to minus 14 only, right? So here what we can see, as temperature is increasing, Kw is also increasing, right? Okay, Kw is also increasing, right? And that's it for this particular page. As you can see here, pH plus POH is equals to 14, right? Okay. Now let's calculate the pH for different things. Hanji, let's calculate the pH for different things. Array, pH means this thing, this pH scale I was talking about, 1 to 14. Usually we draw it from 1 to 14. It can be from 1 to 13 if you talk about temperature is increasing. It can be 1 to 12 also. But usually we draw from 1 to 14 where we say 7 is neutral, till here it is acidic, till here it is basic. This is what pH scale I was talking about. Right? Okay? Okay? Chalo. Now let us talk about the different formulas that you will see for pH. Right? Okay? Yes. Okay, now let us talk about strong acids. If you have one strong acid, you have two strong acids, what will be the pH value that you will tell? Okay, got it? Yes, students? Let us study that. Talking about the strong acids, if you have one single strong acid, like you have HCl, right? Okay, for example, you have HCl. If someone is saying that what is the pH? pH will always be equal to, in all these cases, pH is equals to this thing only. In all these cases, pH is equals to minus log of H positive of that solution. But now the main condition is to find the H positive of that solution. That we will find everywhere, right? So if you talk about the first condition here, strong acids, you can see here, this is H positive. pH of that solution is H positive from acid plus 10 raised to power minus 7. This is from water. This is from water that we have, right? Now what you will see here, when H positive, that means, for example, I am saying that H positive is greater than 10 raised to power minus 6. And this is your concentration of water, right? And here the concentration of acid is this much, right? This is the concentration of acid. That means now the concentration of water and acid are comparable to each other. That is the reason we have to ignore the concentration of the water, right? That is, we have to ignore this 10 raised to power minus 7 if the concentration of acid is greater than 10 raised to power minus 6. But if I say that the concentration of acid is, let's say the concentration of acid is this much and the concentration of water is very little, right? It is less than or equals to 10 raised to power minus 6. In that case, we don't have to ignore it. We will use 10 raised to power this from acid plus 10 raised to power minus 7, which is from the water. Is this thing clear to everybody? About if you have a single strong acid, then you will ignore 10 raised to power minus 7, when you will not ignore 10 raised to power minus 7. Is that clear? Right? Okay. Got it? Next is for strong base. Strong base like NaOH, BaOH twice, same thing. Right? Now in this also, when you talk about OH negative of that solution, that is equals to OH negative from base plus 10 raised to power minus 7, that is from the water. Because water also has OH negative ions, right? So that is why from the water we have 10 raised to power minus 7, right? Okay. Now, when you will ignore this and when you will not ignore this. If your OH negative concentration from base is very large, it is more than 10 raised to power minus 6, then you will ignore 10 raised to power minus 7 here, and the concentration of solution of this OH negative will be equals to the same concentration of OH negative from the base. But if the concentration of OH negative is less than equals to, it is not comparable with the water, then we will not ignore it. We will also give full respect to this H raised to power minus 7 here, right? Okay. Now, that was the thing. So basically, mostly from these 4 cases only the questions are asked, right? Okay. Next is 2 strong acids. You have 2 strong acids. First is NM1V1, right? What is, ma'am, M1V1? I am just taking an example. You have HCl and let's say you have H2SO4. We know that HCl gives 1 H positive, it gives 2 H positive. Here N factor is going to be 1, here N factor is going to be 2. So N factor I have denoted by N and M. How many H positive it is giving? What is M is the molarity, V is the volume of this acid, V2 is the volume of this acid. So formula is, when you have 2 strong acid, it is NM1V1 plus MM2V2 divided by V1 plus V2. What is NM1? Normality. What is NM1? N factor into molarity is nothing but normality, so it is N1V1. No, N factor into molarity is N2 normality, so it will be N2V2. So answer will be N1V1 plus N2V2 divided by V1 plus V2. That is the formula, right? Okay. Now, okay, yes. Now, next is 2 strong bases. Let's say you have 2 strong bases, like you have NaOH and you have BaOH twice. We know that, see, why I was teaching the very first page of ionic equilibrium, I taught you strong bases and acids. Problem is, students, they cram the full formulas. Then they don't know that BaOH twice is a strong acid or a weak, is a strong base or a weak base. That is the reason students get confused in the exam that, ma'am, I don't know which formula to apply to calculate the value of pH. Because, ma'am, I didn't know whether it's a strong acid or a weak acid. So we know that it's a strong acid. All alkaline earth matter are weak, but BaOH twice is a strong base, right? Now, here it will be normality here is 1, molarity, not normality, N factor here is 1, N factor here is 2 because it is going to give us 2 OH negative. So it will be NM1V1 plus MM2V2 divided by V1 plus V2. In case of normality, N into M1 is N1, M into M2 is N2. So it will be N1V1 plus N2V2 divided by V1 plus V2. Right? Okay, yes. How many of you need break? Chalo, after this theory part, I'll give you the break, and so that after the break, we will get. Uh, Array, chalo, let's firstly complete the theory part. Then I'll ask you if you want break or not. If you want break, then I'll give you break. If you don't want, then we'll continue. Right now, next is if you have strong acid and strong base. Now, ma'am, why we are subtracting it here? Reason is, let's say from strong acid you have 100 H positive. From strong base you have 120 OH negative. Now 100 H positive and 100 OH negative, they will neutralize each other and you will be left with 20 OH negative only. You will be left with 20 OH negative, right? That means overall the solution will be basic in nature. So you have subtracted these two things because some H positive, strong H positive and OH negative will neutralize each other. That is the reason we will subtract things here. So here simply you don't have to remember which is larger, smaller, just simply say mod of, you will take it as positive, mod of NM1V1 minus MM2V2 divided by V1V2. It is H positive of solution. After that, just take the pH there. Next is for weak acids. For weak acids, Ka is equals to, simply, like if you want to know exactly, ma'am, what you have written here for weak acids, so I'll just explain you here, right? A simple thing. Let's say you have a weak acid. Let's say you have CH3COOH. It is giving you H positive plus CH3COO negative, right? This is what it is giving you. Initially, you take the concentration as C. Here it is 0, it is 0. After that, C minus, if I take it as alpha, I am saying that X is equals to alpha. Ma'am, why you are saying here X is equals to alpha, right? Okay, because this concentration that I have taken as C, let's say I am saying that this is C minus Cx, this is C, this concentration is nothing, this is C minus, initially it was C, na? So it will be C alpha only, Cx only, right? This is also Cx only because this much amount will be taken out now. So now, can I say that alpha is equals to amount that is dissociated is C alpha? Initially it was C. So Cx, wait a minute, alpha is equals to amount that is dissociated is Cx. Initially it is C. So alpha will be equals to X, right? So instead of X, can I write here alpha, alpha, alpha? Can I just write here alpha? It is C alpha, it is C alpha, it is C alpha. Okay, C alpha, C alpha, C alpha, right? Because that much is taken out, right? So here Ka will be equals to, product is C square alpha square divided by C, take C common, it will be C alpha, it will be C alpha square divided by 1 minus alpha. We know that alpha is very less, degree of dissociation is very less, na? So it will be approximately equals to 1, it will become equals to C alpha square, right? So that's why directly I have written here that Ke is equals to C alpha square. Directly I have written it here. Now you can remember these things if you want. If you don't want to remember, just ignore these things here, right? So what we have to do here, H positive is equals to, we know that what is H positive. H positive I have taken it as C alpha is equals to C alpha. You multiply this C alpha. What is alpha? Here alpha is equals to under root Ka by C. You put it here, C multiplied by alpha is Ka by C. So it will be equals to under root CKa. This is what I have written here. Okay, so you want to remember that, you want to remember the formulas, you can, but I would advise you, you don't need to do that, right? So H positive is equals to under root CKa, right? Just take the ratio of two different acids, right? It will be C1 Ka1 divided by C2 Ka2, right? Now, if you take the log here, this is H positive is equals to C Ka, this is half. You take the log here, then the formula that you will get is this one. This is the formula that you will get here, right? This is the formula that you will get here. Why I am telling you about this particular formula? The reason is you can do the derivation as well, but in the exam you don't need to do the derivation. Don't waste your time in doing the derivations, right? So just remember this thing, that it will be equals to pH is equals to half pKa minus log C. Just remember this thing, right? And weak acid and strong acid, this is the formula. It is not asked to you, right? Never it has been asked. So I have just written it for to take away the risk here. You want to remember this, you can, if you don't want to take that load, you can also ignore this particular formula here, right? Okay, right? Okay, Ji? Yes. Now, next is buffer solution. Now, guys, what is a buffer? Acha beta, focus here, right? What is a buffer solution? A buffer solution is which does not change its pH, right? So, if I am saying that buffer solution can be of three types. It can be acidic in nature, it can be basic in nature, it can be salt, right? Like a neutral, or you can say neutral, right? So in these three different kind of buffers, what are the different things that you can use, right? So in acidic buffer, the formula is pH is equals to pKa plus log salt by acid. In case of basic, it is pOH is equals to pKb plus log salt by base. In case of neutral buffer, it is pH is equals to half pKw, or you can simply say pKw is nothing but it is 14. So you can say 7 plus half pKa minus pKb, and this formula is frequently asked. This formula is frequently asked to you, right? Okay. Now, buffer capacity, again, not a very important topic, right? So you can just ignore this as well. For NEET, you can ignore this. For NEET, you can ignore the formula of buffer capacity, right? If you want to see number of H positive OH ion added per liter of solution divided by change in pH, both the terms will be given to you in the numerical as well. Numerical only, they will give simple direct question will be asked here, right? Next is, ma'am, what is buffer range? Buffer range is how much pH you can change here, right? So if you talk about that, for an acidic buffer, pH range will be pKa, this pKa minus 1 to pKa plus 1. For a base, it will be pKb minus 1 plus pKb plus 1. That is going to be the buffer range here. Next, we have salt hydrolysis. Again, you have three kind of cases here: anionic, cationic, and anionic both. So in this, you have a strong acid, you have a strong base, weak acid, weak base. Basically, strong acid and strong base will not show any salt hydrolysis. That will be shown only by if any of it is weak, right? So if there is weak acid, that is called anionic, right? If there is weak base, that is called cationic. If both are weak, that is called cationic as well as anionic salt hydrolysis, right? Okay. Now, if you talk about the anionic salt hydrolysis, the example that are given to you, that this is CH3CONA. So in this, what you are using? You are using weak acid, that is CH3COOH plus NaOH. A strong base was used here. This is formed from strong acid and weak base, that is HCl plus NH4OH, that is a weak base. This is formed from a weak acid, CH3COH plus a weak base, that is NH4OH, right? Now, a simple trick about the formulas I am giving you, right? A simple trick. If any of it is weak, that means I am talking about anionic or cationic salt hydrolysis. In that case, just remember this particular thing. Just remember these three things. You don't have to remember this. You don't have to remember this, right? Okay. So what is it? Now, here I am saying KH is equals to KW by K weak. KW by K weak. We know that for anionic, acid is weak. So it will be Ka, right? Now, H is equals to under root KH by C. Under root KH is what? Under root KH is KW by Ka. KW by Ka multiplied by C here, right? Done. Next is, what is H positive? H positive in weak acid, we are calculating H positive, that is C into H. C into H. H is given to us. H you can calculate from here, right? From there, you can see that this will be equals to square and this is under root. CC will be cancelled out. It will be CKW by KA. That will be the answer here. Right? Okay. Now, same thing I will apply to cationic salt hydrolysis when you have weak base. Weak base means it will be KH is equals to KW by K of weak. Weak is base, so it will be KB. What is H? H is equals to under root KH by C. Under root KH. What is KH? That is KW by KB. KW by KB. That is the value of H. Right? H is a degree of hydrolysis. Right? What is OH? OH is C into H. This is C into this H. Right? So you can just directly say OH negative is equals to C multiplied by, this is KW by CKB. It will be cancelled. So it will be C multiplied by KW by KB. Right? Just remember C into H. From there you have this formula. The headache, ma'am, KH is hydrolysis. Yes, H is the degree of hydrolysis and KH is hydrolysis constant. Right? Okay. So the headache of learning these formulas is over now. You just have to remember these three things and you are done with the formulas, because the main thing is to remember the formulas of salt hydrolysis. Right? Next is, what is pH? pH, see, pH is basically from this formula only. It is calculated taking the log, then multiplying it by minus. But you don't have to do that. Right? If you forget about, if you in the exam you're blank on this part, ma'am, I totally forgot that what was the formula, then you can definitely derive it in the exam. Try to learn this formula because it is time consuming to derive the formula. Right? Okay. So learn it as, for an ionic it is pH is equals to 7 plus half. It is acid is weak, so it will be pKa plus log C. If you have strong acid plus weak base, it will be pH is equals to 7 minus half pKb minus log C. Right? Okay, that will be the formula here. Right? Okay, what to do? Arey, nothing to do. You just have to study. This is what you have to do. Right now, so you don't have that many problems in your life. You just have to do is study. Think about the problems that your parents must be facing to raise you, to to earn money so that you get roti, you get to eat something daily. They are doing so much for you, right? Okay. So in front of them, what you have to do, you just have to study as much as you can, right? Okay. Chal. Now, if you have weak acid and weak base, what to do then? Weak acid plus weak base. So KH is equals to KW by K weak. Both are weak, so it will be Ka multiplied by Kb. Now the formulas of H and H positive has changed. Here H was equals to under root KH by C. Here it is H is equals to only under root KH. Right? Okay. So it is H is equals to under root KW by Ka multiplied by Kb. That's it. Take the under root of this and you will have the formula of H here. What is the formula of H positive is equals to KH into H? Ma'am, here to H positive was C into H. Here it is Ka into H. Ma'am, why you have taken this? Because it was easy to remember this formula, right? So it is Ka multiplied by H. H is what? If you multiply this by Ka, you take the square and under root here. This will be cancelled and you will have Ka multiplied by Kw divided by Kb. That is the formula of H positive. Got it? Yes, everybody? Got it or not? Yes, students? Now, the last part of ionic equilibrium is, solubility product. Let's talk about the solubility product. If you talk about Ax, By give rise to X, A raised to power Y positive, B and Y, B, X positive, right? Now, the value of KSP is X raised to power X, Y raised to power Y, solubility of X plus Y, right? That means this is a simple direct trick here, that stoichiometry of this raised to power this, stoichiometry of this raised to power this, solubility of x plus y, that is going to be the final answer here, right? That is going to be the final answer here, right? If you have common ion effect, and let me tell you, right now the trend is mostly the questions they are asking you is based on solubility product, right? Most of the question that they are asking you is based on the solubility products, right? So solubility product is equals to, right, if you talk about a common ion effect, CaF2 give rise to Ca2 positive, F negative, right? We know that if the same thing is happening, right, we have the same kind of compound which is giving us one of the same ion, F is the common ion here, right? So according to NaF, the concentration is 0.1. According to CaF2, the concentration is 2S, because its solubility is 0, 0. After this, it is S and it is, wait a minute, it will be 2 na? It will be 2. It will be 2F, that's why it is 2S here, right? Now, because these are the common ions, that is why here also it will be 0.1 into 2S. Here it is 2S plus 0.1, right? So the concentration is going to be same here, right? That is why we know that 2 into S plus of this is solubility is very small as compared to this 0.1, right? Right, so that is the reason that will be ignored, right? And here it will be equals to 0.1 only. So answer will be Ksp is equals to solubility of this raised to power the stoichiometry constant, that is 1. Here it is 0.1, it is 0.1 only, raised to power the stoichiometry constant, that is 2, and that you will get your answer here. Got it? Yes, everybody? Yes, students. Now the last and a very, very important part here, very, very important part, that is number of ions, right? Based on number of ions, how you will solve this. Acha, this question has been asked. Either though you can do this question with the help of like like a numerical problem, you can solve this, or you can directly solve these questions with the help of a simple concept here, right? With the help of a very, very simple concept. Now, two things can happen. Number of ions, they can be same or they can be different, right? Okay. If the number of ions are same, right? Number of ions, they can be same or they can be different. If the number of ions are same, in that case, it will be equals to solubility is directly proportional to Ksp, inversely proportional to the precipitate. They can ask you which precipitate will be formed fast, which precipitate will be formed slow. They will give you some examples. I'll also show you one of the question like this. If the number of ions are different, mostly same can also be asked, different can also be asked, right? So if the number of ions are different, the result of Ksp and PPT are same only. That Ksp and precipitate formation are inversely proportional to each other, but solubility here will be dependent on the number of ions if the number of ions are different. Okay? Yes? Okay, students, got it or not? Okay, Tanuja, okay, I'll talk to the team about this. Okay? Yes. Got it? Beta, I am telling you the tricks only. What I am telling you here, right? Tricks only I am telling you, right? Okay, if you want to understand the equilibrium, if you have never understood equilibrium, then you have to see my depth lectures, right? Okay, and if you're going for a revision, right, tricks, then this, what I have completed in last 2 hours, this is what you need. Okay, students, got it? Huh. Chalo guys, that was about the theory part of equilibrium. Now let me know if you also want to do next part with ma'am. After this, give break, ma'am. Acha. If you want break, then write BB in the comment section. Okay? If you want break, then write B break in the comment section. You can just find that on Vedantu NEET English, equilibrium, whatever chapter you are looking for. Right, Diksha ma'am? Right, you're looking for equilibrium, chemical equilibrium, Diksha ma'am. I have taken separate lectures for chemical and ionic equilibrium. Okay? Yes. Only Sukanya wants break. How many of you want break? Yeah, let me know in the comment section. How many of you are looking for break? I'm waiting for answers in the comment section. I'm waiting for answers. Acha, why don't you guys like the session? I can see that you guys don't love me that much. Is it? Sometimes I feel that you guys are not, you don't love chemistry or you don't love me. You're like, okay, we don't care about Diksha ma'am. We'll not like it. We'll never subscribe. We'll never comment on Diksha ma'am's lecture. Some kind of revenge you are taking from me. Now even I am asking you, now even no reply as if you are, I think, is it too much cold that you don't want to type anything? Is it? I too can't see that. I can't see that. I have to ask you like literally, beta, please speak something, say something. Only for serious aspirants, right? Chalo. Chalo guys, I'll give you break for 10 minutes, okay? I'll give you break for 10 minutes and after that we will start the lecture, right? Okay? So I'll give you break for 10 minutes. After that, we will start the lecture. The time starts now. Okay, at 8:45, I'll see you all. Thank you so much, guys. Thank you. But I want to see more of your love, right? That I can see only with the help of comments and with the help of likes and shares that you give me, right? Because I can't see your expressions on daily basis, right? Okay, chalo. I'll see you all in 10 minutes. Hello, hello, hello. Okay, students, so let us start the questions now. So, everybody, I am back. So, are you ready for questions? Everybody in the comment section, are you all ready for the questions? Yes, students, are you all ready for the questions? Just give me a second. Okay. Okay. Ready? Chalo. Now let us start the session, start the questions without wasting any time. The target is to complete the question by 9:30 p.m. Okay, by 9:30 p.m. we have to complete all the questions here. So coming up with the first question on your screen, that is, wait a minute, why can't I see the first question here? Right. So the first question coming up on your screen is, which of these is least likely to act as a Lewis base? Okay, which will not act as a Lewis base. So everybody in the comment section, let me know which is least likely to act as a Lewis base. First is CO, then F negative, F3, BF3 and PF3. Least likely. Lewis base is the one which is electron rich. So as you can see that BF3 is electron deficient. So it will never act as a Lewis base. So answer is C is the correct answer, right? C will turn out to be the correct answer. Next question is, for a reversible reaction. Now they are saying that for a reversible reaction, that is this much, Haber's process is given to you. We know that Haber's process is exothermic in nature. They are saying that you want to shift this equilibrium towards the forward side. So if you want to shift this equilibrium towards the forward side, so what you will do, now as you can see here, by reverse reaction, this is the reaction equilibrium shift in the forward direction. Concentration decrease. If you decrease the concentration of H2, it will try to increase the concentration of N2 and H2 and it will shift on the backward side. So that means this is not the correct answer. By increasing pressure and decreasing temperature. So when you increase the pressure, it will shift on the side where number of moles are less. Where number of moles are less. Number of moles are less on which side? They are less on the forward side only. So it will shift on the forward direction. Now, when you decrease the temperature, we know that for an exothermic reaction, temperature is inversely proportional to the rate constant, right? So when you decrease the temperature, rate constant will increase, right? That means it will shift on the forward side. So answer will be, again, it is forward only, right? So answer is B is the correct condition if you want this reaction to happen in the forward side, right? Very good. High pressure and low temperature, right? Okay. Next question is, which of the following salts will give highest pH in water? Highest pH in water. Highest pH, Na2CO3, CuSO4. Highest pH means if you talk about these salts, they should be at least made from strong acid, right? Okay, so highest pH in water will be given by Na2CO3, definitely not, right? If you talk about KOHCl and NaOHCl, right? Okay, yes, students. So I'll just give you one elimination. I'll give you H2CO3 is a weak acid, so it cannot be the answer. This is CuSO4, again it cannot be the answer, right? Acha, what about KCl and HCl, NaCl? Highest pH in water. Highest pH in water is given by which of the following? Yes, students. Highest pH in, wait a minute. Acha, highest pH, wait a minute. Highest pH they are asking you, na? Highest pH means they are asking you, pH highest means they are asking you weak acid. Because this is a pH, na? This is 14, this is 7, this is 7, this is 1. Higher side means they are asking that you should have a weak acid, right? So if you talk about the acids here, this is H2CO3, right? This is H2SO4. This is HCl. This is HCl. This is also found from HCl. So as you can see that H2SO4, HCl, these are strong acids and this is the only weak acid. So it will only have the highest pH value. So answer is going to be A is the correct answer. Right? Okay? Yes. Basic only they are asking you. Right? So A is going to be the correct answer because it has a strong base and weak acid. Right? Okay? Next is, for a given exothermic reaction, now they are saying you have an exothermic reaction. That means delta H is this. Kp and Kp dash are equilibrium constant at temperature T1 and T2. Right? Heat of reaction is constant in temperature. Range between this, it is readily observed that are equilibrium constant, temperature T1 and T2, assuming that the heat of reaction is constant in this temperature range. Now they are saying what will be the value of Kp dash. If you talk about this belongs to Kp dash, this is Kp. We know that for an exothermic reaction, temperature and K are inversely proportional to each other, right? Okay. So can I say that if I say mostly we are increasing the temperature only, right? Okay. So T2 is greater. That means Kp will be greater than Kp dash, right? Because they are inversely proportional. So answer is going to be what? Everybody, answer is going to understood, na? So what we have done here, because we know that temperature and rate constant are inversely proportional to each other. So how you can directly solve this? Because temperature we are increasing, right? If nothing is given about the temperature, that means we are increasing the temperature. Temperature is increasing, that means rate constant we are decreasing. So answer is going to be C is the correct answer, right? Okay guys, understood? So C is going to be the correct answer. Next question on your screen, everybody. The KSP of Ag2CrO4, AgCl, AgBr, Agi. Four things are given to you, right? So I'll just write these four things here. Ag2CrO4, AgCl. Oh God, can you see that bike? What's this craze with wilt? And that too also at this time. I think people have gone crazy or what. Okay, KSP, we have four compounds here, right? Now, they have given you the values. Which one of the following salts precipitates last? Right? Firstly, tell me, are the number of ions same or different here? Number of ions here also it is Ag, wait a minute, if you see this here, number of ions they are talking about now. So this is having 3 ions, right? This is having 2, it is having 2 ions, it is having 2 ions. Now KSP is given to you, they are asking you the value of the precipitate. So whether the number of ions are same or different, it doesn't matter. KSP will always be inversely proportional to the precipitate formation. So if you see any value which has minimum value, they are saying the last. Last means the slowest precipitate will be formed by that thing which has maximum KSP value. Just find out from this thing which has the maximum KSP value. It is -17, -13, -10, -12. Which has the maximum value of KSP out of these 4. Yes, students, which has the maximum value of KSP out of these. Maximum value, right? Which one of the following salts precipitate last? Wait a minute, they are asking precipitate last or what? Which one of the following salts will precipitate last? If AgNO3 is added to the solution containing equal moles of NaBr, this and Na2CrO4, right? Okay. So answer is going to be KSP. Answer is going to be which thing? A Yes, answer is going to be which thing which has the maximum value there. Wait a minute. Last means this is minimum, that should be maximum. So maximum value is for 10 raised to power minus 10, no? AgCl, AgCl has a maximum value, no? AgCl highest KSP value. So answer will be what? Highest KSP value is of which thing? Highest KSP value. They're asking the precipitates, right? Okay, so the highest KSP value is of AgCl, right? So AgCl is on the C part. So answer is going to be which? Everybody in the comment section. Everybody. So answer is going to be that C is the correct answer. Got it? Yes, everyone. Yes, everyone. So you just have to find out that KSP and PPT are inversely proportional to each other, and that's it. Now, let's see. Next is, if the value, if you talk about the value of an equilibrium constant for a particular reaction is this, then the equilibrium, the system will contain, if the value of the equilibrium constant for a particular reaction is this, okay, equilibrium constant is given to you, it is given to be this one, the equilibrium of the system will contain similar amount of reactant products, all reactant, mostly products. That means it is greater than, Kc is greater than 10 raised to power minus 3. That means it will be product dominated, right? Okay, it will be product dominated, right? Okay, so answer is going to be what? Okay, so answer is going to be what? Answer is going to be that mostly products you will see in the answer. PPT, precipitate formation is inversely proportional to that, right? Okay, next is the solubility of AgCl will solubility product this 0.1 of NaCl solution would be. Now, as you can see here, solubility again they are asking you, but this is with AgCl, and there is also one common ion that they are asking you. So Na, this is based on common ion effect. Just remember, this is based on common ion effect. That means what will happen here, if you have AgCl, right, this is Ag positive and this is Cl negative. If I am taking it as this is solubility 0, 0, this is 0, then this is S and this is S. I am also taking the common ion here. That common ion is NaCl give rise to, this is Na positive and this is Cl negative. Now, here what we can see, because this is given to be 0.1, this will be 0.1, this will also be 0.1 will be formed here, if this is 0.1. So that means here we will add 0.1, right, because the common ion, it will turn out to be 0.1 only. So answer of KSP is going to be, KSP equals to S, that means solubility of Ag positive, multiplied by 0.1. KSP is given to be, KSP is given to you. So solubility will be KSP divided by 0.1. What is KSP? KSP is given to be 1.6 multiplied by 10 raised to power minus 10 divided by 0.1. Right? Okay. So answer is going to be B is the correct answer. Right? Okay. Next is, wait a minute. Answer is going to be 0.1. A is the correct answer, because what will happen here? 0.1 multiplied by 10, so it will be 1.6 into 10 raised to power minus 9. So A is the correct answer. Okay, A will be the correct answer. Next is the percentage of pyridine that forms, now they are saying the percentage of pyridine that forms pyridinium ion. That means pyridine is a base which is accepting H positive. In a 0.1 molar aqueous pyridine solution, Kb is given to you. They are asking the percentage of pyridine here, right? Percentage of pyridine, how you will calculate? That means first you have to calculate the concentration here, right, students? So first you have to calculate the concentration. Everybody, Chalo. Now, what you will do here, simply what you will do here, pyridine is acting as a weak base. So what we will do, weak base formula is Kb is equals to C alpha square, just like weak acid is Ka is equals to C alpha square. Now concentration is given to you, Kb is given to you. Just calculate the value of alpha here, that is degree of dissociation. They are asking the percentage of pyridine. Now this much is dissociated, right? This much is being dissociated. So alpha percentage is going to be this multiplied by 100, that is 0.013% is going to be the correct answer, right? 0.03%. So answer is A is the correct answer, right? Okay ji, chalo. Next question is the equilibrium constant for the following. They have given you the equilibrium constant here. You just have to solve it, right? Equilibrium constant K for the reaction. It is based on that multiplication of N, division of N, right? On that concept, right? So now here what you will do, this is 2 into NH3. This will be reversed. This will be reversed. Just remember this will be reversed because this is on the opposite side. Earlier it was on the right side, now it is on the left side, right? 2NO, you don't have to do anything with 2NO because it is same as it is. If it is reverse, it will be 1 by K1. It is same, right? And you have added it, right? When you add, here it is 3 into H2O. So this will be multiplied by 3. This will be multiplied by 3, only then you will get 3 H2O, only then you will get 3 by 2 O2. When you will add O2 here, it will be 3 by 2 plus 1, that will be 5 by 2, right? So here we can say that this will be K3 raised to power 3, right? You have added these two things with this one, so it will be 1 by K1, right? This is K2 multiplied by K3 cube, right? So answer will be K2 multiplied by K3 cube divided by K1. So D will be the correct answer, right? Okay, chal. Next is, which of the following statement is not correct? Now I have to tell which of the following statement is not correct. Enzymes catalyze mainly biochemical reaction. Incorrect they are asking, na? So enzyme catalyze biochemical reaction, that is right. All the biochemical reaction we use enzymes, they are same as catalyst only, right? It's just that they are natural. Coenzymes increases the catalytic activity of enzymes, right? They help in that. So it is also true. Catalyst does not initiate the reaction. That is also true. Catalysts just help in increasing or decreasing the activation. They just alter the activation energy, change the path. The value of equilibrium constant is changed in presence of a catalyst. That means if you talk about the value of equilibrium constant, that will be changed in presence of the catalyst. That's why I told you that catalyst can alter the path, but they will not affect the equilibrium constant. So this is the incorrect statement. So answer D is the correct answer, right? Next is the concentration. The concentration of Ag positive ions in a saturated solution is this one. In a saturated solution, solubility product they are asking you. Saturated solution, guys. So it is Ag2CO4, right? What will happen? Ag positive, 2Ag positive plus C2O4, 2 negative, right? Solubility product they are asking you. What they have given you? Concentration they have given you. Concentration of this solution. Concentration of Ag positive in this solution. In this solution, you have 2 Ag positive. That means the concentration of 2 Ag positive is 2.2 into 10 raised to power minus 4. The concentration of C2O4 2 negative will be half, because here you have 2 ions, here you have 1 ion. So it will be half of this. So it will be 1 by 1 into 10 raised to power minus 4. Right now they are asking you the solubility product. That means they are asking you the value of Ksp equals to, this is 2.2 into 10 raised to power minus 4. It is square because here stoichiometry is 2. It is 1.1 into 10 raised to power minus 4, right? And just solve this, do the calculation, you will get your answer 8 plus 4, right? 12, and this is 2.222, right? 242, right? 2.42. I think the answer will be 2.428 plus 4. I think C will be the answer. B? Wait a minute. After doing the calculation, what we get? After, acha, this is square also, na? This is square also. 2.2 into square. Then you have multiplication with 1.1. So you will get the answer as, just do the calculation, you will get the answer as 5.3 into 10 raised to power minus 12 is what you will get. Right? Next question is, following solutions were prepared by mixing different volumes of NaOH and HCl at different concentrations, right? So at different concentration, you have these values. So which formula to apply? Strong acid and strong base, simple formula will be applied. H positive solution. H positive solution is equals to, let's say N is for N1 is for acid. So it is N1 M1 V1 minus of N2 M2 V2 divided by V1 plus V2. This is the formula that you will apply, and then they are asking you the different concentration, pH of which will be equals to 1. pH they are asking you of which will be equals to 1. So that means here they have given a lot of questions here. So what you will do, n factor of all of them is 1 only. So even erase this N1 and M1, right? So what you have to do for the first case, it is H positive of solution. H positive of solution or OH negative of the solution will be equals to, right? That will be equals to 60 multiplied by this. This will be 60 multiplied by m by 10, 6 plus 4, right? Divided by 100. And that will be equals to 10 by 100. And that will be equals to 10 raised to power. That will be equals to 10 raised to power minus 1, right? If you talk about solution, P1 will be equals to, acha, minus you have to do, na? Oh, by mistake I have added it. It will be minus, no? So 6 minus 2 is nothing but that is 2 by 100. 2 by 100 will not be equals to, pH will not be equals to 1, right? Second is, when you have 55, this so definitely will not be equals to 1, right? 55 by 10 minus of 45 by 10 divided by 100 equals to, right? So very complicated this calculation. We will solve it later. Firstly, let us see if we get the answer with something else, right? So third is 75 multiplied by 1 by 5 plus 25 multiplied by 1 by 5 divided by, this is 75 plus 25, this is 100, right? So here it will be 5, right? 5, 1, 5, 5, right? 5. This I really doubt it also. 20 by 100. This is also coming out to be 20 by 100, right? This is also not coming. Acha, minus. Why I am doing plus plus, yaar? Why I am adding it, yaar? Why I am adding it? So this will be 15 minus 5 by 100. Now it is coming out to be 1. This is 10 by 100. That is 10 raised to power minus 1. Yes. So this is 1, right? As you can see, log of this particular thing, it is equals to 10 raised to power minus 1. That it will be, because here the concentration of acid is more. So that means acid is the dominating factor. So pH we are calculating here, right? So it will be minus log of this, that will be equals to minus 1 multiplied by minus 1, that is 1. So answer will be C is the correct answer. So C also option C is in the D part. So D is the correct answer, right? By mistake I did that, right? Okay. Chalo. Next is, yes, we are also human beings, guys. Which one of the following condition will favor maximum formation of product in the reaction? Acha, this is same as that what we have done before, right? Now for an exothermic, T is inversely proportional to K. So if you want to make it in the forward direction, then what you have to do? In the forward direction, if the temperature is low, then the rate constant is high. So temperature should be low, right? So next is pressure. Pressure, if you increase the pressure, it will go on the less number of moles, right? So when you increase the pressure, it will go on the less number of moles, because here moles are 1, 1, that is 2, and on the reactant product side it is 1. So answer will be C is the correct answer, right? Okay, C is the correct answer. Next is conjugate base for Bronsted acid. You have Bronsted acid, conjugate base they are asking you. H2O. H2O, Bronsted, if this is an acid, it will take out H positive, it will become OH negative, right? Then for HF also it will take out H positive, it will become F negative. So answer will be B is the correct answer. Yes, guys. Next question, I am waiting for your answers here. pH of saturated solution of CaOH twice is 9. The solubility product of KSP of CaOH twice they are asking you. It's a very, very interesting question. Okay, because here what they have given you two things here. They have given you pH here. pH of this solution. pH is given to be 9. That means the concentration of H positive is going to be 10 raised to power minus 9. Right? Or you can just say if pH is given to be 9, pOH is going to be 5. So the concentration of OH negative is going to be 10 raised to power minus 5. Right? Now, if you talk about this particular reaction, that is CaOH twice, it is going to give you Ca2 positive plus OH negative. Now, concentration of OH negative is already given to you, isn't it? Yes, students, I am waiting. This is your question now. This has become your question. Yes, students, I am waiting for your answers. I am waiting for your answers. I am waiting for your answers, guys. We have done this kind of question before as well. Hanji. So, what is the concentration of OH negative? B. Chalo, let's see. You just give me the steps only. What is this given to me? I have taken this as 10 raised to power minus 5. This is 2 OH is 10 raised to power minus 5. We know that if this is 2 OH, then half of this will be for Ca because it has 2 ions, this is 1 ion. So this will be 10 raised to power minus 5 divided by 2. Right? Now they are asking for KSP value, or what they are asking? The solubility product they are asking. So I'll just write the solubility product here. KSP is equals to the concentration of Ca2 positive and concentration of OH negative raised to power 2. So it will be 10 raised to power minus 5 by 2, and this is 10 raised to power minus 5 square. This is 10 raised to power minus 5. This is 10 raised to power minus 10 divided by 2. Right, what is the answer you're getting? 0.5 multiplied by 10 raised to power minus 15. Right, okay. So answer is going to be what? Everybody. Answer is E. Okay, chalo. Next is the pKb of dimethyl. Now they are saying the pKb of dimethylamine, pKa of acetic. Just directly put the value of pH and you will get your answer here. The pKb of dimethylamine and pKa of acetic acid are given to be this and this. Okay. The correct option for pH of dimethyl ammonium acetate solution. That means you are making a solution out of that acid and base. Right? Okay. So both are weak only. Amine is also weak acid. It is also weak acid, and this is also weak base. Right? So when both are weak, which formula you will apply here? Both are weak, then which formula you will apply here? From which particular thing it is from? Yes, students. From which particular, is this buffer, is this simple pH, or is this salt hydrolysis? What kind of question you can see here, right? One thing to I've already, that's why I told you na, that 1 degree, 2 degree, 3 degree amine are weak base, right? Acetic acid is a weak acid. So when both are weak, you have weak acid and you have weak base. This is a question of salt hydrolysis, right? So pH will be equals to 7 plus a half of pKa minus pKb, right? Okay. Huh. Very good. So 7 plus this is half, pKa is given to us as 4.77 minus pKb is also given to us 7.27, right? Now just calculate this and tell me what is the answer that you are getting here, right? Okay, what is the answer that you are getting here, guys? Very good, very good, very good. Karthi, Pratibha, Isran, Mansi. Very good. Shabash. So that means if you're able to predict that what kind, ionic equilibrium is all about predicting that what formula will be used. Otherwise, once you know the formula, it's not a big deal to answer it. Okay? 7.75. Chal. Yes, that is in the option. Yes, the option is coming out to be 7.75. So A is the correct answer here. Yes, guys. Very good, very good, very good. Very good. Chalo. Now, guys, we have completed chemical and ionic equilibrium as well, right? But now I want to know in the comment section why you guys don't want to study chemistry. What chemistry has done, right? What chemistry has done to you that you don't want to. Is your chemistry too good that you don't want to study it, right? Or you want to study something else, right? So let me know in the comment section what exactly you need for chemistry so that I can come up with that particular thing, right? Okay, chalo. Okay then guys, bye-bye, take care, see you all, take care of yourself, and that's it. I'm waiting for your comments in the comment section, because when you tell me that this is what ma'am we want, then only I can deliver that thing to you, right? Okay. Don't forget to hit the smash button, like button, and also comment down below, and also share this among your friends, so that, because it takes a lot of effort to make these notes for you, to pick up questions for you. So that's why share this among your friends as well. Okay, chalo. Okay then, bye bye, take care, see you all, bye bye.